Okay, so we are continuing with chapter 4, problem examples today. As usual, kita akan go through the examples slowly. Kalau ada soalan, you can interrupt me as usual. Kalau nak bagi komen pun boleh. No problem with that. Okay, so last time we talked about this platform diver. And we discovered that when we started the motion of the diving motion, right? We started with KE is equal to 0 and we had some potential energy associated with it, gravitational potential energy. And that gravitational potential energy is called mgh ataupun the equation is mgh, and it is in relation ataupun it is with reference to the ground. We are assuming our ground is h equals to 0, therefore this is h equals to 10. If your reference point is the ground, the next time you do this example again, let's say you want to know what is the energy of potential energy over here, you need to have the same reference point. Kalau korang tukar reference point to become this part, let's say, contohlah, let's say you wanted your reference point to be this. This is h equals to 0, therefore this would be h equals to 5. Then all your other, nak jawab semua soalan yang berkaitan dengan soalan ni, kena pakai reference point yang sama. But since we said we want our life to be easy and we are saying that our ground is h equals to 0, so kita akan pakai h equals to 0 dekat sini lah. So this becomes 10 and this becomes 5. My point here is that your reference point can change depending on the question. Kadang-kadang dia nak susahkan kita, dia akan cakap, okay, the reference point is 5 meter above the water. So that can happen. When that happens, just use the MGH equation as usual. Kita tengok kan when we change the reference point. Yeah, we already talked about this key example, and this is when we changed our reference point daripada sini kepada sini, if I'm not mistaken. Or have we? Ke belum Dengan kelas korang belum kot. Okay, tak apalah, kita akan go through. Alright, so this is what happened with the diver. We discovered that this is the full potential energy. When we dive, KE kat sini kosong. As we dive, our KE increases. Where does it come from? Where does the energy come from? It comes from the gravitational potential energy. Gravitational potential energy reduces and it goes ataupun it transforms into kinetic energy. When it reaches the reference point, your gravitational potential energy becomes 0. Where is the energy lost to? It is lost and transformed to become kinetic energy. So at this point, you would know that the diver has a great velocity compared to at this point ataupun at this point. Bila kat sampai kat hujung, when all the energy is transformed, you know that your KE is the maximum. When your KE is the maximum, your V is also the maximum. Okay, so that was the diver problem. I have a question here. Nida, kenapa ni gaduh dekat chat? Fokus. Okay. So moving on. Okay, this one. Kita tak buat lagi yang ni. Kan, tak buat lagi kan? So kita stop dekat diver tu. Jangan sedih-sedih, jangan gaduh-gaduh, okay? Okay, so this is... Betul kan korang? Kita tak buat lagi kan soalan ni kan? Semua sensitif hari ni. Okay. Saya pun nak sensitif jugalah. Nak sensitif juga macam korang. Okay, so hit the ski slope. So this is an example from your textbook as well. If I'm not mistaken, dia punya page... Alamak, saya tak bagi page pula. So it is example 5.8 from your textbook, ebook that is available on your web assign. So combine, this is the goal, combine the conservation of mechanical energy with work energy theorem. So EI equals to EF. If we have friction, we would have EI minus WNC equals to EF. And then it wants us to find out what is W equals to KE. So EI minus WNC equals to EF. Okay, so if you rearrange this, it becomes WNC, kita bawa ni ke sini, so jadi positif. So our EI minus EF. So jadi positif kat sini tapi terbalik. EI minus EF. Selalunya kita tengok EF minus EI, right? EF minus EI, then this would be minus WNC. Dua-dua betul. But I'm just trying to show you guys that this is from the work energy theorem. If we rearrange the conservation of energy, it is the same as the work energy theorem, whereby the change in energy is equal to the work done. But this one is specifically for KE. Yang ni boleh jadi apa-apa sahaja. Sorry, I don't know what's going on. So this will be delta KE ataupun delta UG. So boleh macam-macam delta US, because this is related to EF minus EI. So the work energy theorem yang that we learned about is related to the change in kinetic energy. But in reality, mathematically, this is also correct, because this is basically just EF minus EI, and this would be your work loss from non-conservative forces. Okay, so everyone okay? This was a little bit of recap yang susah sikit. Okay, so let's continue with this example. A skier starts from rest. So we immediately know that our KE is equal to 0. So this is going to make our life easier, I hope. So starts at rest at the top of a frictionless incline. So WNC is equal to 0 as well. So that's great. WNC tak wujud ataupun equal to 0. Of height 20 meter. So this is the height, H. At the bottom of the incline, kat bawah sini, B, the skier encounters a horizontal surface where the coefficient of friction between the skis and snow is 0.2. So here, the friction does not exist. So WNC does not exist there. But from B to C, ada friction. So WNC wujud kat sini. But WNC tak ada kat sini. So we can start to imagine that we would have one EI equals to EF over here, and one EI equals to EF over here, but our EI kena minus with WNC. So we have two, how do I say this? Two parts to this problem. Find the skier speed at the bottom. So it's asking us to find velocity at point B. So let's label that. What is the V over here? We know that our V up here is 0. This is what is V over here. And then how far does the skier travel on the horizontal surface before coming to a rest? So daripada V kat sini, we know that this would be our new U as in initial velocity, and we want to know how far will it travel before the V becomes 0. So this is part 2 lah. So we are going to ignore part 2 for now. So let's do part 1 first. Okay, so this is the strategy. I like reading the strategy in the textbook because kadang-kadang saya belajar pada strategi ni juga. So going down the frictionless incline is basically no different than going down a slide from the previous example, if you guys still remember, and is handled the same way using the conservation of mechanical energy to find the speed VB at the bottom. So it's telling us, hey, just use EI equals to EF because this is what is going on. And then on the flat, okay, this is part B. Nanti kita baca kemudian. So EI equals to EF. Expanding this, we would get KE plus U. U as in US ataupun UG. So in this case, it's only UG. And this is initial. And then we have our KE final plus UG final. Okay. So now we know that our KE is equal to 0. And our UG down here is also equal to 0. How do I know it's a 0? Because this is going to be my reference point. H equals to 0. How do I know it's H equals to 0? Because they said, because if I'm starting from here as H equals to 20, then 20 meter down below should be a 0. Let's say I want to say this is 30. H equals to 30. The distance between this and this is 20, therefore my reference point has to be 10. So it depends on how you are labeling the figure. They just told you here and here is the distance is 20. You can label your reference point as anything, but of course we want our life to be easy, so we are going to label our reference point as 0. But it's not necessary to be 0. This is what I'm trying to say. So H, if it's 10, this has to be 30. If this is 0, this has to be 20. If it's minus 5, It has to be 15. So it depends on what you are putting as your value. 0 and 20. 0 and 20, okay. So this would be UGH MG at the top of this hill is 20. And this is going to be 1 over 2 MV final squared, where V final is at B. This is our V final at point B. So senang je lah kan. So UG, this is MG 0. And this is 1 over 2 M0 squared. So basically, we're just trying to solve this. M cancels out with M. G times 20 times 2 divide square root of that, you would get your V final, hopefully. I hope I'm doing this right. 9.81 times 20 times 2 square root. So dapat 19.81 as our V final. Okay, let me double check the answer. Okay, sama So this is the velocity at point B. So we're not done yet. So part B, how far does the skier travel on the horizontal surface before coming to a rest? Okay, so here we are on a horizontal surface whereby only the kinetic energy, only the velocity changes. Remember, for work energy theorem, the thing that needs to change is only the velocity. So we can use that here. So work energy theorem states that it is equal to the work done is equal to the change in kinetic energy. Do we have a change in UG here? Do we have a change in UG from B to C? Ada tak? No, because?
Dia berubah secara horizontal.
Dia berubah secara horizontal. And what is MGH related to?
Related to apa? Yang itu tak tahu.
Okay. So tadi you said it's related to horizontal displacement, which is correct because MGH ataupun UG is related to vertical displacement only. If there is no vertical displacement, walaupun ada displacement horizontally, we still don't have UG because it is related to vertical displacement only. Okay? So jawapan tu dah tepat tapi tak sampai hujung. Tapi betul. Because H is equal to 0. Okay, thank you Haikal. Haikal nak jawab juga. Okay, so there's no vertical displacement here. Dia tak naik, tak turun. So we would say there's no UG involved. Okay, so continue. So W equals to delta KE. So here I would say that 1 over 2 MV final squared minus 1 over 2 MV initial squared. And we know that this guy would come to a rest. So this would be equal to 0 because V is equal to 0. Our U would be this value. And this is W. 1 over 2 M. What is our M? M tak ada. And then V is 19.81 squared. Aha, so now we're stuck. So how do we find this W? Apa kaitan dengan how does the skier travel before coming to a rest? How can we relate this to what is going on here? Or is this approach wrong? Okay, jom kita baca strategi On a flat surface. Okay, on the flat, rough surface, use the work energy theorem. Okay, this is what we're doing. We're using the work energy theorem. With W and C equals to work friction equals to minus FKD ataupun friction times distance. So it's telling us to use the work energy theorem, but this guy is equal to W and C. How did we get this equation? Macam mana tiba-tiba boleh ada equation ni? So siapa nak jawab? Ada friction. Naziha is saying ada friction, betul. But where did this equation come from? Macam mana tiba-tiba boleh equate dengan W and C? Okay. So the answer, okay, ada orang nak jawab lagi. Ada lagi tak nak jawab? Come on. Let's try. Tapi dia suruh neglect air resistance. Betul. But we have friction. Friction is not air resistance. Friction is between surface. So Feli is saying work done to overcome the friction force. Betul. Okay, Haikal nak jawab. Because non-conservative force. Yes. Non-conservative force betul. But I'm asking you, okay, this is work energy theorem. Kenapa saya boleh equate dengan non-conservative force? So Haikal is saying F equals to F, W equals to F cosine theta. Kenapa theta? Theta lah. Theta pula. Ni theta ni siapa? Girlfriend awak ke? F cosine theta S. Force tu guna friction. Okay. Okay, so these are very good guesses. So let's discuss about it. Okay. So my question is, I'm going to repeat the question here. We know that work energy theorem is net work is equal to change in KE. My question is, kenapa kita boleh equate with W and C? Okay. So let me try to write this somewhere else. I need space. Let's duplicate this. Okay, so remember that I told you the work energy theorem is actually from EI equals to EF. Masih tak percaya eh? So EI equals to EF. So in this case, this is our EI where we started, initial energy. This is our EF. Okay, so in this situation, okay, abaikan dulu situation ni. Our EI and EF is U plus KE and it is equal to U plus KE, right? And if we have friction, this equation would be U plus KE minus WNC equals to U plus KE, where U is either UG or US or both. Tak kisah. So now this is our general equation. Now we are going to apply it here. EI equals to EF. Tapi ada WNC. So in this case, our U does not change. So we can say, okay, U is not relevant. So these are both equal to 0. Because kat sini mg times 0. This is also mg times 0 because we are at the reference point. We're not moving vertically. So these are both 0. Ataupun if you don't want to say H equals to 0, you want to say H equals to 10. mgh, mg10 minus mg10 is still a 0. They would cancel out with each other. So U ni memang dah tak ada, tak wujud sebab dia sama. So now we're left with KE initial, KE final. So this would be KE final minus KE initial equals to minus WNC. Where does this look? Is this familiar or not? Yes, it should be. It's the work energy theorem. So the work energy theorem came from this equation as well. Tak adalah came from here, tapi sama lah. It's the same. But the only thing that's different is that we have the minus sign here. So if we want to get rid of the minus sign, we could just flip the equation. KE initial minus KE final. You get your WNC. Tak kisahlah asalkan this equation is correct. It's correct lah. So now we can equate this to our WNC. Is everyone okay with this derivation? Tak lah derive pun, substitute je. Everyone okay eh? So this becomes minus WNC. Minus untuk the work energy theorem that we used before, waktu kita tak belajar WNC lagi, kita cakap okay, kalau positive work done, velocity is increasing. If negative work done, velocity is going to decrease. Here we know that it's going to decrease. Our U, excuse me, our U is 19.81 and our V is going to be 0 because it is going to come to a rest. So velocity dia akan berkurang sampai jadi kosong. So the work done must be negative. So this is why it's a negative because we already know it's going to be negative. Okay, so kalau tak nak letak negatif ni pun tak apa. So WNC delta KE, you would get this as 0 minus 1/2 mv initial squared. So this would be 0 minus something. 0 minus 1 over 2 m 19.81 squared. So our W is now WNC, which is force times distance. In this case, the only force that is acting here ataupun the non-conservative force here is friction. So friction is mu r. Okay, we still can't solve it. We want to know what is D. How far does the skier travel? How can I get rid of R and M? I don't want these unknowns. I don't care for it. How can I get rid of R and M? Anyone? Anyone wants to guess? I just want to solve for D. I don't really care about mass. mg cosine theta. Feli is saying mg cosine theta. Haikal is saying theta equals to 0. Oh, ni yang tadi. So, but yang latest is mg cosine theta. Okay, Feli, why is it mg cosine theta, Feli?
R is the opposite direction with the mg cos theta.
Okay, but we are on the ground. So, okay, let's draw our free body diagram. That's a very good point, actually. So we are on the ground.
Oh yeah. mg.
So you want to correct your
No cosine theta. Yeah.
So R is equal to?
mg.
mg, yes, correct. So Feli is saying R is equal to mg because our free body diagram is down here, not up here. Kalau up here, maybe ada mg cosine theta and whatnot. But we are not on an incline. This is not me, this is you. So this is your mg, this is R, and we have friction, and we don't have a pulling force. So if I'm assuming you guys are not flying, your net Fy would be 0. Therefore, R minus mg. R minus mg. So R is equal to mg. So this becomes mu R ataupun mg. So this is what is given as mu. Mu is 0.21. R is mg. We don't know what is our d, and this is going to be equal to minus 1 over 2 m 19.81 squared. Yay, we can cancel it out. So you can solve for D because G is just 9.81. So I'm going to use my calculator and find out if I get the same answer as the textbook. Times 9.81. Malasnya, ada orang nak kira kan tak? Kita kira sama-sama Kita buat siapa yang lagi laju. Divided by 2. Tapi saya nak buat lambat-lambat sebab saya nak kalah. Divided by 0.21 sebab saya malas. Alamak, saya rasa saya tak dapat lah. Berapa yang korang dapat? D? Saya lupa nak square. What is this? Times, kena divide 19.81. Dia tak orang yang dah dapat. Divided by 2. Divided by 0.21. Divided by 9.81. I got 95.25. Sama tak? Macam mana korang boleh lagi lambat pada saya ni? Saya dah lemah kalkulator ni. Oh, dah ada orang jawab dah. Sorry. Sama. Kenapa Syaki dapat 196? Oh, lupa divide. Okay. Okay. So everyone got 95.25. Don't forget units. It is in meter because this is distance. Let's see. Yay, we got it. Okay, so that is how we use the work energy theorem when we have friction. Kat sini, when we use EI equals to EF, I told you the WNC has to be negative. So sebab dalam ni equation negatif lah. Tapi when we use the work energy theorem, this thing will tell us whether it is a positive or negative. Yeah, it will tell us whether it's positive. Kejap. I have to have the negative sign. I have to think kejap. Minus baru boleh positive D. So kena ada minus, sorry. Has to be a minus. Tadi saya cakap suka hati nak letak. Jangan suka hati letak negatif tu. Nanti korang confuse. So this becomes negative and the negative cancels out with the negative. So baru korang dapat D yang positif. Kalau letak negatif nanti dapat D negatif, salah. Okay, so it only makes sense if you have the negative sign. Saya suka hati sebab saya tahu benda ni dapat apa kan. So jangan ikut saya, letak negatif tu, nanti korang confused. So negative over here, also negative over here if we are talking about work, non-conservative work done to overcome the friction force. Yes. Okay, letak negative, okay. Alright, so that is it I think for this example. So now we go to our spring force example. Ada soalan tak pasal the previous example? Do you guys have any question? Cantik ni tulisan saya dalam ni. It's usually very ugly.
Ada doktor.
Tak ada Okay. So I'm going to continue with spring problems. Okay. So this is a horizontal spring, as you can see over here. Okay, so this is a horizontal spring. Use the conservation of energy to calculate the speed of a block on a horizontal spring with and without friction. Okay, so still sama juga, EI equals to EF. When we have friction, we have the minus WNC in our initial side. So the problem is a block with mass 5 kilogram, okay, is attached to a horizontal spring. This is our spring over here with a spring constant of 400 Newton per meter. The surface the block rests upon is frictionless. If the block is pulled out, okay, this guy is being pulled out from 0 to xi and released. Find the speed of the block when it reaches the equilibrium point. Okay, so do you guys still remember what equilibrium point is? Find the speed when x is 0.025. Mula-mula dia suruh cari speed kat sini. Lepas tu dia suruh cari speed dekat sini. Halfway through. This is 0, this is 0.05, this is 0.025 kat tengah-tengah ni. Repeat part A if friction acts on the block with coefficient mu k. Okay, kita abaikan dulu C. So this is the strategy. In parts A and B, there are no non-conservative forces, so conservation of energy can be applied. Okay, tu je hint dia. That's pretty nice. Not really nice. Okay, so this is our horizontal spring. Remember, I told you guys previous class that the equilibrium position is when we are not stretching the spring. We're not doing anything. We're not compressing it. We're not stretching it. Spring tu tengah santai. Di tengah tak buat apa lah. It's not doing anything. Di tengah chill. So this, I told you, the end of the spring, I label this as x equals to 0 because I want to define a point where it's not doing anything. And then when it is doing something, I can quantify that displacement. So when we stretch it, it will become elongated, and the displacement of this end of the spring would go by some displacement. And in this case, they stretched it up to x equals to 0.05 meter. Okay, I'm going to repeat myself here. So when we are not doing anything to the spring, the displacement is x equals to 0. We also call this as equilibrium point. Okay, whenever they say equilibrium point, it just means it is at x equals to 0. And then when I stretch it, I am stretching it by 0.05 from the equilibrium position. And then I release it, dia akan meluncur. It will go back to its original position. Apa ni? Daripada sini lah. So dia akan meluncur balik, pergi sini balik. Dia akan go back to its original position because this is what a spring does. Logically, it will go to its original position, x equals to 0. Okay, so now it's asking us find the speed of the block when it first reaches the equilibrium point. So our equilibrium point is now our final destination. So our EI starts from here. When I'm stretching it, that is my EI. When I release it and it goes back to the equilibrium position, it is the EF. So now we can write our equation EI equals to EF. And what do we have here? Do we have UG? We don't have vertical displacement, so UG tak ada. We have US, spring potential energy, and we also have KE. Korang dengar dia cakap emergency. So I don't know what emergency he's talking about. Boleh abaikan. US final plus KE final. So US is 1 over 2 kx squared 1 over 2. Sorry, dia cakap saya goreng pisang pula tiba-tiba. So weird. Okay, 1 over 2 kx squared plus 1 over 2 mv squared. So again, this is our initial, final. Apa yang kita boleh potong kat sini? So we started with tarik and we know that it's not moving yet. So our KE is actually 0. And then when we're releasing it and it goes back to the equilibrium point, do we still have US or not? It goes back here, kat sini, this point. Does it have US or not? Does it have spring potential energy? Saya rasa saya patut buat poll lah. I want to do a poll. Okay, let's see. Kejap, bagi saya buat poll kejap. Macam mana nak buat poll lah? How to make a poll? Am I sharing screen? No, I'm not sharing screen. Saya tak tahu apa emergency. There's no emergency, I promise. So boleh abaikan. How to make a poll? Poll maker. Okay, let's do it. Why not? Does the spring, does the spring have have spring potential energy when it goes back to the equilibrium position ataupun point, point. Answer yes, no, I am not sure. Dr. Nat is cute. So allow multiple choices, yes. Voters must enter their name, yes. Create poll. Nak share? Okay, share. Copy link. Okay, sharing now. Stop share. Okay. Nah, vote. Sebenarnya macam break lah juga sebab saya penat. Okay, love you too. Private to me. Oh, sorry. Saya terhantar dekat soh je. sorry. So mesti saya confused. Okay. Sorry so. Jadi mangsa keadaan. So where do I see the values or results? Sorry, values pula. Kenapa korang tak vote lagi? Vote cepat. Oh, dah ada vote dah. Korang tahu kan boleh vote multiple choice. So this, I am expecting 100%. Dr. Nat is cute. So chat. Kena multiple how? How macam mana? Oh, boleh satu vote je Alah. Okay. Tak payah tulis Dr. Nat cute pun tak apalah. Husni. Boleh lah. Tengok ni Naziha. Vote 2. Tipu Wafa pun vote 2. Siapa MM MM 007. Boy. MM siapa? Husni je yang tak vote saya cute sampai hati. Cik tak adalah. Tak kisah pun. Let's see. Jawapan dia no. Ada orang jawab yes. Amy jawab yes. Alif jawab yes. So siapa lagi nak jawab yes? I will miss you doctor. Siapa ni? Balkis, Jana jawab yes. Oh, Amy jawab semua ke? That's not fair. Amy, mana Amy? Jangan ikut Amy, jangan ikut Amy. Okay, so siapa nak jawab yes kat sini? Kalau yes, kenapa? Saya nak tahu kenapa yes. Okay, kalau no, kenapa? Sudah tak bagi nama pun, ya Allah hai korang ni. Okay, tak apalah, nasib baik ni bukan graded. So 24 votes for no, 7 votes for yes. Total is 33. Oh, Ayub tak jawab saya cute Okay, tak apa. Oh, ada 3 orang tak vote saya cute. Atira pun tak vote saya cute. Amy ambil jalan selamat. Okay, so we have around 30 plus lah, 30 plus votes. So that's okay. So 24 of you jawab no and 7 jawab yes. 25 said no. Okay, so let's continue with our discussion. So that was just for fun saya main je. Tak payah saya cakap saya cute pun tak apa. Saya tahu saya cute dah. So stop sharing. Okay, screen share. Okay, so let's continue. So some of you are saying that we have spring potential energy when we reach the equilibrium point. And why is that? Kenapa Kenapa orang cakap yes? Ada jawapan ke memang bantai je? Okay, so remember our potential energy, spring potential energy punya equation is 1/2 kx squared. If our equilibrium is equal to 0, therefore, dah tahu dah kan jawapan dia kan? Jawapan dia kosong lah. So look back at the x displacement. If it has displacement, then you would have PE. If it does not have displacement, then from the equilibrium point, then it is equal to 0. So we know that for the final part of this equation, our PES ataupun US is going to be equal to 0 as well. Okay, so now we try to solve it. 1/2 400 xi squared is 0.05. It should be in SI unit meter. Ada orang lain nak jawab ke? Let me see. Okay, lepas tu 1/2 m mass of the block 5 kilogram, and then V final refers to the velocity over here. This is where we defined our EF. When we define our EF to be this point, our X is also equal to 0 and our USF is also equal to 0. If you define your E final somewhere else, then that condition tak apply lah. Kena tengok tempat lain macam mana. So now we can solve for VF. This is squared. Jawapan dia so this cancels out. Oops, silap. Ada orang dapat jawapan tak? Kenapa lambat sangat saya kira ni? Square divided by 5. Square root of that. So dapat V final as 0.45 meter per second. Okay. So let's see if that is the answer, because I don't remember. 0.45 ataupun 0.447. Sama lah. Okay, so that is what we need to do if they ask us what is the velocity at the equilibrium point. Kita start when we stretch. When we stretch, it was not moving yet. KE is equal to 0. Sama macam situation diver tadi. So diver tadi, when it started the diving motion, we are assuming it started from 0. Dia belum dive lagi tapi dia nak start. Tapi PE dia dah ada. PE dia because he is at a height. And then when he reaches the final point, he converted all his UG to KE. Kat sini pun kita pun start kat sini from 0. KE equals to 0. Motion has not started. Mana lagi? This one, KE equals to 0. We have not started the motion. So this is kebanyakan situation akan start with KE equals to 0 lah. Okay, I'm just trying to point that out to you guys. Next, find the speed when x is equal to 0.025. So now our EF is shifted. This is no longer our EF. Whoopsie. This is no longer our EF, but our EF is over here. So I'm going to label that EF. Oops. Let me get rid of this. 0. So this is x equals to 0.025. Midway of that extension. So dia daripada sini, dia patah balik. So sebelum dia sampai sini, dia patah balik ke sini. What is the V final here? So that is what the question is asking. 0 to 5. So now that becomes our E final. EI is here, E final is here. And we want to know what is the V over here. So now kita kena adjust kita punya equation. So EI equals to EF. This is part B. Let's duplicate this. So this is now part B. EI is still equal to EF. We still don't have friction. This is still the same equation. Now let's discuss it. Okay, so 1 over 2 kxi, we started with 1 over 2, 400. Our initial is still 0.05. And we started with a KE of 0. Sama juga sebab kita still tarik, belum motion belum start tapi dah ada potential energy. So initial situation is our KE is equal to 0. And then when we reach 0.025, do we have UG or not? Ni tak ada pole. Do we have UG or not? UG pula, US, sorry. Do we have spring potential energy or not? When we reach this point. Ada ke tak ada? Yes, we have. Okay, sebab equation kita adalah E equals to ataupun PES equals to 1 over 2 kx squared. If our x is not 0, then we would have potential spring energy. So 1 over 2, 400. But now our final position is 0.025. It's not 0. So dia akan jadi 0.025 lah. And then 1 over 2 mv final squared. So m is 5. Forgot to put this. So m is 5. So you can solve for v final. So v final would be, I don't know, 400 times 0.05 squared divided by 2 minus with, let's see, 1 over 2 times 400. 0.05 squared tolak 0.025 squared times 2 divided by 5. So saya dapat V final, oh silap, square root 0.387. Kalau korang perasan, web assign ataupun the textbook likes to use 3 significant figures. So instead of 2 decimal places yang unit fizik pakai, the textbook uses 3 significant figures. So dia tak nak 0.39, dia nak 0.387, dia nak 3 significant figures. So this is the answer if I'm correct. Let's see. 0.387. Yay. So faham ke everyone? Does everyone understand? Does anyone want me to repeat this explanation? Oops, this one. Okay, where is it? Oh, this one. Anyone wants me to repeat? Does everyone understand? Everyone okay with the term equilibrium point? Everyone understands why KE is 0 initially? So no questions? Okay, so let's continue. Kalau soalan boleh interrupt me. And then part C. So part C, if friction acts on the block with coefficient mu k 0.15, find the speed when x is equal to 0.025. Bukan, sorry. It starts from here. Repeat part A, if friction acts on the block. Part A is find the speed when it reaches the equilibrium point. So situation spring kita tadi, kita nak tahu kat sini E final kita. This is our E initial. Let me duplicate this again. So this is our E final. Okay, this is our E initial. And it's asking us if we have friction on the surface, what is the V final here? Okay, so any guesses? Would the V final be greater or smaller? Guesses. Would the V final be greater or smaller? Kalau ada friction. Kalau ada friction, logically kita akan slow down ataupun akan increase in speed. Kita akan jadi smaller. Yes, smaller. Kejap. Bisa buat apa tu? Okay, let's continue. Slow down. Betul, kita akan slow down. So, bila ada friction, logically what happens is when we are travelling on a rough surface, dia susah nak jalan kan? So, kita akan slow down. So, I'm going to expect a smaller velocity. If our equation is right and we are plugging all our values correctly, we would get a smaller velocity. Kalau korang dapat velocity lagi tinggi, maksudnya memang salah, buat balik soalan tu. Okay, so use your logic, use the equation, tengok balik, betul tak? Does it make sense or not? So this is how I approach my problems. Okay, so EI minus W and C equals to E final. And then E initial, what do we have here? We have KE and US, but our KE is 0, but I'm just going to write that down. US KE minus W and C equals to US KE, and that's it. And then kita label kita punya initial, final, final. So now I'm going to plug in the values. So USI is 1/2 400 and our X is 0.05. Remember, you need to define your initial place and final place. Baru clear apa yang kita nak solve. WNC and then KE USF is equal to 0 because this is our final position where X is equal to 0. And from our poll, most of us jawab there's no US. Opa is working. Don't cry. Okay, so minus WNC equals to 0 plus 1/2. M is 5. Ada orang menangis. Oh, sorry, I'm not supposed to laugh, but I'm just like that. So dia tengah menangis sebab he's looking for his grandmom. So V final So if you're wondering what kind of parent I am, I'm the type who laughs when they fall down. So it's not good parenting. Okay, so 1/2 KX squared plus 0 minus WNC equals to 0 plus 1/2 MV final squared. Okay, so we don't know what is our V final. We have, what information do we have? We have this guy. What about our WNC? We need to talk about our WNC here. So WNC equals to friction times distance. What is my friction and what is my distance? Oh my God, kita tak discuss lagi ni. Okay, friction and distance. What is my friction here? Friction is mu R. What is my R? Let's look at our free body diagram here. Dah ada free body diagram dah. What is my R? R is equal to mg. Why? Why is it equal to mg? What condition did we use to assume that Okay, ada orang nak jawab. Horizontal plane in contact. Okay, betul. Tak terbang. Betul Lutfi. The phrase I was looking for is it's not flying ataupun Fy equals to 0. Afifah bagi saya. So Fy equals to 0, we are assuming it's not flying. It's only going horizontally. If there's spring, nak terbang. So this would not apply. So kalau dia terbang, tak apply. So now it's not moving upwards or it's not flying. Therefore, I can say that my net in the Fy is equal to 0. And in my y-axis, I only have r minus mg. Remember, n is just the reaction force. So r is therefore equals to mg. Mu mg. What about my d? What is my d here? Is it 0.05 or is it 0.05 times 2? Which one is it? Do we need another pole? So is it 0.05 or 0.01? Okay, let's see. Let's make a poll. Okay. Sebab saya tengah semangat nak buat poll ni. Let's duplicate. And also I'm just wasting time a little bit. Back to poll. I hope I need to screenshot this before this goes away. Nanti tak ada bukti korang cakap saya cute. Okay, so capture. Does the spring, okay. How do I edit this? I need to make a new poll code. Semua orang tengah berhati-hati. Jangan discuss saja. Tiba-tiba tak nak kasi discuss. Boleh discuss. So let's do our new vote. Kenapa saya nak buat vote? Sekatilah kan. Straw poll. Cuma saya nak buat baru. Okay. New. Create poll. What is the distance traveled? Sorry. What should be the value of D? Should be the value of D in W and C. Okay. 0.1, 0.05 meter or 0. Share. Kenapa tak ada 0 kat sini? Gendutnya. Share, copy link, and then go back to you guys. Stop sharing. Okay, everyone. Okay. So Molly dengan Shaky saying 0.05. So saya ikut Shaky. Mana boleh ikut-ikut? Okay, cuba teka kenapa. What is the distance traveled by the friction? Is it the entire length of the spring? Is it twice the length of the spring? Is it twice the length of the extension? Saya tadi tengok siapa yang jawab. Back to poll. Oh, korang as guest. Okay, never mind. Oh, ni anonymous. Oh, sukalah kalau anonymous ni. Okay, fine. So, 2 vote je untuk 0.1. Sian dia. What is it? You want TV? Okay, wait. Okay, please keep voting. What is it? Okay. Kenapa tak cukup vote ni? Kejap, let me refresh. Come on guys, kenapa tak vote betul-betul? Come on. What is your vote? Baru berapa orang? 35. Ada orang tak vote lagi ni. Kita ada 41 kat sini. Ada orang yang tertidur ni. Siapa yang tertidur? Okay. 31, 37. Siapa lagi? Belum vote. Oh, ada orang tak vote ni. Okay, I will identify these people Cik. Okay, let's continue. So stop sharing. Let me. Okay, memang 37 je. Okay. Ada kisah romance pula dekat kita punya chat. So sharing screen. So the answer is actually D, that is from EI to EF. This is what we're talking about, right? EI to EF. So the D should be 0.05. So betul lah, ramai orang yang betul. Tahniah, okay? Tahniah. Tapi tak ada hadiah. So now we can substitute that into our equation. Ada orang nak tanya soalan ke percutian ke rumah sendiri? Okay, so let me substitute this. Sorry. So I'm going to put this. Apa ni? Oh, this is my name. So this goes here. mg over there. And what is that? 2. Minus So this is minus and this is whatever 1/2. Mu adalah 0.15 and m is 5. G is should just letak betul. Let's write this. So 1/2 400 0.05 squared plus minus WNC. So minus WNC is friction. Mu 0.15. R is mg 5 and 9.81. Mu mg times with D. D is from EI to EF. Our question is about EI to EF. So itu saja distance korang sebenarnya. If you're confused about the distance, find out where your EI is, find out where your EF is. If EF is, that is your distance. Displacement. Remember, work done is force times displacement. Displacement tempat yang kita jalan je lah. Tempat yang tak jalan buat apa nak kira. So D is 0.05 and then this is equal to 1/2 5 V final squared. So V final, we are expecting a smaller V, remember, because we are losing energy to non-conservative forces and that energy cannot be recovered because it is non-conservative. Panjangnya nak kira. Okay, 400 times 0.05 squared divided by 2 minus with 0.15 times 5 times 9.81 times with 0.05 times 2 divided by 5 square root 0.22 0.23 0 meter per second. So what was the part A to our question just now? Our part A, we got the value, did I get rid of it? We got our value for part A 0.447. When we have friction, our V final became 0.23. It slowed down because we lost energy to the environment from friction. Let's see, betul ke jawapan saya? Saya tak tahu. Oh betul, 0.23. Betul ke? Let me see the actual answer. Oh betul, 0.23. This is part C. 0.23. So this answer is in your textbook. You can go refer to it. Tapi saya tak berapa suka cara equation dia tulis. So if you can make sense of it, that's good for you. If not, just follow what we learned in class, okay? Next one. Kenapa? Doktor tak nak layan. Apa yang saya tak faham? Sekejap. Syeki nak jadi doktor tak? Boleh pegang real. Saya tak faham. So, Syeki nak jadi doktor tak? Boleh pegang real. Real? Oh, doktor ni, doktor medical ke? Okay. So, cakap saya garang. Sorry, saya tak garang pun. Main-main je. Percutian ke rumah sendiri, doktor tak nak layan. Kali ni tembak tepat. Tahniah. Haikal di-ignore. Haikal cakap apa? Kenapa? Haikal cakap apa? Saya ignore ke? Sorry. Sorry, okay? Haikal cakap apa tadi? Tak ada pun. Tengok apa Haikal kata. Part Haikal doktor. Oh, Haikal doktor tak nak stay ke? Saya tak boleh stay lah. Saya bukan boleh pilih pun. Kalau saya boleh pilih, saya dah pilih dah. Sebab ramai jawab betul. Okay, saya tak ignore pun Okay, saya okay je. Okay, jangan merajuk Okay, so everyone jangan merajuk. So kita akan continue. Ke kita nak take a break first? Tapi dah 11.30 dah ni. Dah lambat lah sebenarnya. Sekejap, how many examples do we have? 1. Kita lambat sebab kita buat poll tu tadi. Oh, we have 2 more. Is it? Yeah, 2 more. Okay, kita habiskan ni dulu and then we can take a break. Tak cukup Tak apalah, kita take a break dulu after this example Kita siapkan ni dulu. Benda inilah akan diikati. Over tau, saya punya WhatsApp available Telegram pun available. Korang ni berdrama sangat. Jangan drama-drama belum masa lagi. Nanti esok-esok kita nangis-nangis. Hari ni belum nangis lagi, hari ni belajar. Kita kena kental. Esok saya nak masuk impulsive force sebab saya nak tunjuk video Ian. Tapi tak tahu sempat ke tak. Kita cuba Kalau tak, kesian Ian, penat-penat jatuh. Jatuh real pula tu. Kesian tengok. Okay, so this is our example. Sabar saya tak baca chat lagi Jangan cakap saya ignore pula. Saya nak cerita ni. Cerita pasal spring. Okay, so a 50 kg circus acrobat drops from a height. So again, kita ada objek ataupun this is manusia. Kita start from a height of 2 meter straight down onto a springboard. So dia 2 meter ni defined from the springboard from here. So dia dah bagi gambar. Kalau gambar dia tak bagi, kita tak tahu pun 2 meter ni with relation to the springboard. So I'm going to assume that gambar ni memang akan diberilah. So this 2 meter height above the springboard is 2 meter. This is where she is. Kita punya reference point adalah kaki dia kepada springboard. Okay, so it is diving straight down onto a springboard with force constant. This is spring constant of 8,000 Newton per meter. What is the maximum distance does she compress the spring? So bila dia terjun, dia akan ada vertical displacement of H plus D. What is D? D is the amount that she compresses the spring. So sekarang ni MGH kita adalah bergantung kepada H dan juga D. We move from here to here. This is our final position, or this is where she stops. And that is the vertical displacement. So our UG depends on the compression of the spring as well. Okay. At the 2 points, by what maximum distance does she compress the spring? So they are asking us, what is D? What is D? So the strategy, let's read the strategy of this problem. Non-conservative forces are absent. Macam mana kita tahu dia absent? Tak cakap pun. So we are ignoring air resistance here and we don't have any other friction. We're not in contact with a surface when we are diving onto the springboard. So friction memang tak ada. Air resistance pun neglected here. So non-conservative forces are absent. So conservation of mechanical energy can be applied. So EI equals to EF. At the 2 points of interest, this is our EI and this is our EF. Label it. If it makes you confused, label it. This is our EI, this is where we started, and this is where our EF will be. Dekat hujung ni lah, kat tempat dia compress. Okay, let me, tak nampak lah warna orange. So this is EI and this is EF. Okay. What else? At the 2 points of interest, the Acrobat's initial position and the point of maximum spring compression, her velocity is 0. So they are telling us VI is equal to 0 here sebab dia baru nak mula. I know it looks weird, tapi kita akan anggap dia terjun daripada some board. So dia terjun, so kita akan start with KE equals to 0, tapi UG akan ada some value. So KE is 0 there, and when it reaches this board, dia duduk atas board tu kan, ataupun dia berdiri atas board, she's not moving anymore, she's stopped. So dia orang cakap KE can be 0 here too. This is not rather intuitive because selalunya we would try to find out what is the velocity at the end of the motion, right? For linear kinematics ke apa ke. But for energy punya problem, when you're not moving, KE is equal to 0. When you are starting the motion, KE is equal to 0. So it is different than linear kinematics. In energy, different than linear kinematics. Linear kinematics is describing the motion. So kita nak betul-betul nak tahu V apa sebelum, V apa at the end. But for energy, kita akan assume KE is equal to 0 and KE is equal to 0 when it is not moving yet. Ataupun motion baru nak start ataupun motion ending. So I want to relate this back to the diver problem. Okay, remember we started with KE equals to 0. And that is because the diver baru nak terjun, right? The motion tak start lagi, dia tak bergerak lagi. So KE equals to 0. But when he dived over here, we said that the diver had some KE. Because why? Because when it reaches the water, kepala dia kat sini, ni kepala dia, ni badan dia, kan? Bila kepala dia sampai ke air tu tak berhentikan motion dia. It lets the diver go in. So the motion is still there. So dia jatuh ke bawah sini. So the motion is still there. It's not stopping. But when we are talking about the Acrobat, mana Acrobat tu jauh pula. When we're talking about the Acrobat, the board stops the motion. There's no water there. So she's going to stop there. So KE must be 0 there. Just remember kalau di start, 0 KE. Kalau di stop, 0 KE. So the energy is quite simplified lah. Okay. Cuma kita akan confuse sikit dengan linear kinematics. So that is the trick there. So EI equals to EF. We know that we have KE equals to 0. We know we have UG. Our UG is, let's write this general equation first. Okay, UG plus KE. Okay, so this is initial, final. Non-conservative forces is not present. We don't have friction. We are neglecting air resistance. So our UG is now mgh plus d. We started from here. Our final is here. We are going to say this is h equals to 0. If this is h equals to 0, then going up here must be h plus d. Let me rewrite this. Let's say this is y equals to 0. Let's not say it's h because kita dah ada h kat sini. So this is y equals 0. So y over here is equal to h plus d. That is your height. This is final. This is initial. Yeah, macam itulah. So mgh plus d plus 0. And then your UG final would be 0. Because we are going to say this is 0 over here. Plus, sorry, kita akan cakap dia D. Wait. Kita cakap dia KE kat kosong kat sini. We have 1 over 2 kx squared, forgot. We have UG, UX, I forgot, this is a spring. So we have to rewrite this equation. KEF, sorry. So UG plus KE plus US. UG plus KE plus US. So we have the mg, we also have the spring. So kita ada dua kat sini. Suddenly our U represents only one, either UG or US. But here we have both. Okay, so now I'm going to write that down. So KE is 0, US, dia tak start compress lagi. So US is also 0. At this point, dia tergantung kan? Dia tergantung kita tak compress ataupun extend the spring. So X of the spring, the extension of the spring or the compression of the spring is 0. Tak ada displacement lagi. And then UG, when it reaches this point, it will be 0 because kita punya reference point. And then kita cakap KE is also equal to 0 and US is 1 over 2 KX squared. So if K is 8,000, what is our X value here? What is our X value? Anyone? No one? So 50 kilogram. What is our X value? Is it H? 9.81 times 2 plus D. So ada orang nak jawab. Oh, banyaklah pula. Molly, Shaky, Feli is saying D. Okay, so let's try it. 1 over 2 kx squared where x is equal to D. So that makes sense sebab kita punya compression is by D only. It's not H. We started from here. Our compression is D. Now, my question is, should my D be negative or positive? Negatif. So ramai orang jawab negatif. Negatif. So if it is negative, kalau negatif kita square kan jadi positif juga kan. So it doesn't really matter lah here. Betul tak? So kita punya energy ni dia tak kisah. Compress ataupun extend, jawapan dia tetap akan sama. And for MGH, we defined that our initial energy is here and then we go back down. Kita assume this is a positive. So let's stick with positive lah. We are just saying this whole motion ke bawah ni positive We're saying that this whole motion ke bawah adalah positive. You guys can say it's a negative, but this would be negative, negative, negative. Boleh juga. So let's assume it's positive to make our life easy. So semua ke bawah positive. So this would be positive, 2 will be positive, D will be positive. But in energy, sebenarnya it's a scalar quantity. So either you're compressing or extending the spring, your answer would still be the same. It's a scalar quantity. And this guy is squared, it would always have a positive value here. Okay, just putting it out there. Remember kalau force, betul-betul kita kena define. Sebab spring kan ada F equals to minus kx. This is where it becomes really important to define the x. For energy, the square, so macam tak kisah sangat lah. Okay, so let's continue. So 50 times 9.81 times 2 times t. So we would have a quadratic equation here. This becomes d squared. So this is 4,000 d squared. This is minus 50 times 9.81 times, this is minus 490.5 d. So I expand this equation and then 450 times 9.81 times with 2, that becomes minus 98.1. So I expand this equation, I would get 490.5 plus, I would get 98.1 plus with 490.5d. So saya nak rearrange semua ke arah sini sebab saya nak solve quadratic equation dalam calculator and this becomes 0. Okay, I hope everyone knows how to do that. Patutnya boleh lah. Ini simple math sahaja. So go to your calculator, tekan mode 3 kali. Tekan mode 3 kali. Press right. Tekan mode 3 kali. Tekan equation. Tekan kanan. Pilih degree 2. So our A would be 4,000. Our B is 490.5. Sorry, it's a minus 490.5. And our C is minus 98.1. So our answer is D is equal to 0.229. And we would have another answer of 0.107. Which one should I choose? Which one should I choose? So semua orang dah confused ke tak ke? Still positive because square. Still positive because square. So Syaki is saying ambil yang negative code. Okay, so the answer is ambil yang positif Let's see. The other solution, kenapa jawapan kita lain? Sekejap, jalan kiri kita salah kot. Let's see, this is UGI. Let's see, apa yang lain kat sini? MGH, betul dah. MGH plus D 1 over 2 KX squared. Saya rasa saya salah tekan calculator. This becomes 4,000. Ni 4,000 times. Dia dah simplify equation ni. So saya susah nak compare. Malas nak kira balik. Kita punya equation dah betul. Equation kita expansion salah kot. 8,000 tu betul kan? 8,000 divided by 2, 4,000D. Betul, 4,000D squared. 98.1 tu 981. Oh, okay. Mana 98.1? This one salah. Okay. 50 times 98. Sorry. 50 times 9.81 times with 2. 981. Betul-betul. Saya silap. So this is 981. So pakai balik equation. So A is 4,000 minus 490.5 minus with 981. So dapat 0.560. meter or minus 0.438 meter. Okay, so the answer is you take positive one. Ada orang tanya ke? Okay, so remarks. Kat sini dalam textbook ada orang remarks So I like to read the remarks as well. Ada orang struggling ke? Oh, Atira, okay. Okay, so the remarks here, the other solution D equals to 0.437 minus 0.437 can be rejected because D was chosen to be a positive number at the outset. Remember, kita cakap motion ke bawah tadi positif. So kita cakap 2 plus D, semua ni positif. Kat sini pun positif. So semua positif. So jawapan kita pilih pun kena positif. Kalau kita pilih negatif, then kita akan pilih negatif lah. Korang boleh try sendiri sebab saya malas. Nanti korang try dapat jawapan ke tak If you try to choose everything as a negative, you can try that. So a change in the acrobat's center of mass, say by crouching as she makes contact with the springboard, also affects the spring compression. What does that mean? But the effect was neglected. So here we are assuming this acrobat bila dia terjun badan dia tegak je. Tapi sebenarnya in reality people will crouch. They will be making their body smaller. Kalau extend macam ni, bila terjun dia akan buat macam ni kan. Saya tak tahu kenapa. Tapi that has something to do with the center of mass. And there is an interesting video from my other class. Diorang buat pasal center of mass. Nanti saya share dengan korang. When you crouch, your center of mass actually changes. It becomes lower. So you become more stable. When you do like this, your center of mass naik ke atas. So you become less stable. So that is the logic behind it lah when people do like this. Okay. So that is very interesting. I have a video I will share with you later. The spring action of a shock absorber turns a dangerous jolt into a smooth deceleration as excess kinetic energy is converted to spring potential energy. So bila kita terjun, kan kita still from a motion, kita terjun atas board tu kan. So that kinetic energy bila kita terjun tu is converted into the spring. Kalau benda tu tak ada spring, let's say this is Haikal, biasa, and this is the springboard, and tak ada, sorry, this is not a springboard, this is a board on the ground. So Haikal terjun, Haikal akan rasa sakit lah. Bila dia terjun, kaki dia akan sakit sebab kinetic energy tu dia transfer ke kotak, dia transfer kepada the wooden block only, and the wooden block absorbs, kiranya dia tak soft lah, impact tu tak soft. But when we have a spring, and Haikal terjun, saya tak tahu kenapa Haikal suka terjun. So dia terjun, so that KE from Haikal is converted to become US. So dia jadi smooth, baru Haikal stop slowly. Kalau ada spring, dia akan stop slowly. Bila Haikal terjun atas kotak yang tak ada spring, dia akan stop mengejut. Right. So KE mula-mula V, stop mengejut jadi kosong. Kat sini V, dia punya KE convert jadi US. Haikal, kenapa positif doktor? Adam, saya dah menjawab soalan ke pakai remarks ni? Faham ke kenapa dia positif? Kita pilih semua tu plus D tu positif. That's why kita pilih positif in the end. Dah, okay. Okay, nanti kita akan belajar about impulsive force. Ini pun ada kaitan dengan impulsive force. When we have a spring, we are extending the time. Kalau korang ingat video Ian, Husnia and siapa lagi seorang, saya lupa nama, sorry. Gang, team Ian lah, team Ian. Cik Ian ada team pula. Okay, and Afriza kot, saya tak ingat lah. Lagi seorang, sorry. Tapi team korang lah, okay. Okay, next one. I promised you guys a break and then we will attempt this question. So let's take a 7-minute break. If you have any questions, you can ask me. After this example, kita akan tengok video Ian together. Okay, take a break. Sekarang pukul 11:45. Let's come back at 11:52 AM. Okay. Afriza, okay, betul. Dah masa dah ke eh? Oh dah. Oh dah terlebih masa. Sekejap Kejap. Desktop. Strop. Kenapa saya buka ini? Tak nak. Screenshot. Share. Where is it? To airdrop. Done. Close. You gross. Okay, let's continue. Am I audible? Yes, I'm audible. Okay, so let's continue with this example. Use conservation of mechanical energy to solve a problem, and my face is kacau kat situ. Use the conservation of mechanical energy to solve a problem involving gravitational potential energy, spring potential energy, and a ramp. Okay, so we have chats here. Ada soalan ke? Nanti saya nak pergi kedai kucing saya lapar. Pergi lepas kelas Tunggu. Ada satu lagi example ni. Okay. So a 0.5 kilogram block rest on a horizontal frictionless surface. So kat sini kita akan cakap tak ada friction. The block is pressed against a spring. So block ni kita tolak dia. Kita tolak dia. We are pushing this box against the spring. Block. We are pushing this block against the spring and we are compressing it. Bila kita tolak, kita akan compress lah. Bila kita tarik, we are extending it. Having a constant of K equals to 625, compressing the spring by 10 centimeter to point A. So this is 0 referring to when we are not doing anything to the spring, and when it is compressed, xi is equal to 10 centimeter ataupun minus 10 centimeter. We would say minus 10 centimeter if we are assuming to the right is positive. Okay, then the block is released. Kita tolak dia, kita lepas, sudah tahu dia akan ada some kinetic energy because it is going to move. Then the block is released. Find the maximum distance d the block travels up the frictionless incline. So dua-dua ni frictionless So this guy over here is frictionless. Up here it's also frictionless. Find the maximum distance d. So it's asking us to find this d over here. The block travels up the frictionless incline if theta is equal to 30 degrees. How fast is the block going at half its maximum height? So let's ignore this question first. Kita nak tahu berapa banyak dia gerak sampai dia stop. It will need to stop lah if it is moving up an incline and kita define as some distance d. Kejap. Okay, sorry about that. Ada soalan tak? Tak. Tadi bising. Ada orang main gitar pula dah. Okay. Alright, so let's continue. Okay, so we have a block. We are compressing the block. Bila kita compress, kita tahu ada potential energy ataupun spring potential energy. When we compress, that is our initial energy. This is where our initial energy is. And we compress, then we release, akan ada kinetic energy from the potential energy. Okay, so now kita nak kena tahu how far it will travel up to D. Maksud kat sini, our V over here will become 0. We need to know what is our U so that we know how far it will travel. Betul tak? So how do we do this? So let's look at the strategy. In the absence of other forces, conservation of mechanical energy applies to part A and part B. In part A, the block starts at rest. So the block starts at rest. So our tadi EI equals to EF, betul tak? We have EI equals to, kenapa EI saya jarak macam tu? We have EI equals to EF, and this is equal to KE plus UG. UG lagi, US, sorry, US, spring. So this is our initial, and this is going to be our final. Final kita akan ada UG. Final kita akan ada UG. But, how do we solve this? UG, boleh ke kita nak solve macam tu? So KE, US dah tak ada, kita akan ada UG. Aduh, kejap banyak tu gangguan hari ni lah. Ya. So, jangan main kan? So, okay. Sorry. Okay, so EI equals to EF, KE equals, I need to focus lah. I'm already distracted. So, what happened? Tak ada apa-apa pun. Dr. Karam pun. Tak ada apa-apa pun. Macam biasalah budak-budak. Okay, so KE plus US, spring potential. We know this is our EI. And we want to know what is our EF over here. So how do we do it? We need to know what is the U before we climb the incline. Betul tak? We need to know what is our U. So how do we solve our U? So this is quite a confusing problem lah, I would say. So what we need to work with what we know over here. So kita tak tahu U kat sini apa. We don't know what U is here over. What is U? Apa benda ni? We don't know what is our U over here. So we need to solve for that first, right? But the only way I can know U is to solve the kinetic energy over here. Sebab dekat sini, the potential energy is completely converted to kinetic energy. So let us break this problem into two parts. Kita solve dekat sini dulu, and then kita solve dekat sini pula. This is EI to EF. This is our EF. And then we have our EI over here. This is our EF. So kita pecahkan problem ni kepada dua parts. We solve our first part first, dekat potential energy and also kinetic energy here. Okay, so KE plus, so this becomes US. So EI equals to EF, frictionless, so tak ada WNC. KE, when we start, we compress it, motion has not started, so this becomes 0. This is 1 over 2. K is 625, and we compressed by 10 centimeters, so that is 0.1 squared. 1 over 2 kx squared, right? We're compressing by 0.1 meter. So that is initial energy. So KE, kita nak cari KE kita, and our US at this point, at the equilibrium, it should be equal to 0. Sebab apa? Because 1 over 2 kx squared. When our x is 0, then our potential energy is also 0. How do we know it's 0? 0 is when it returns back to its original state. Ataupun it returns back to when it is uncompressed or unextended. Dia tak buat apa-apa lah, dia tengah chill. So that is where you define your x equals to 0. When your spring is here, the potential energy is also equal to 0. Please keep that in mind. Okay, so kinetic energy, we are trying to find that. mv final squared at this point, specifically at this point, plus with 0. Spring potential energy is 0 over there. Okay, So now we can try to solve for V final because we already know what is mass. So mass is 5. Need to put that in. V final squared. Okay, so 625 times with 0.1 squared divided by 2. Okay, and then times with 2. I should have cancelled that out, but tak apa. Divided by 0.5 squared. Silap, 0.5 je. Alah, kena kira balik. So 625, let me cancel this out first. Ada orang dapat jawapan ke? 625 times 0.1 squared divided by 0.5. This squared belongs to here, not the 0.5. And then square root. Saya dapat jawapan. Berapa jawapan V final korang dapat? Alamak, kenapa ingat kalkulator saya ni? 625 times 0.1 squared divided by 0.5 square root. 3.54. Okay, so that's the answer harapnya. Ada orang dapat lain tak dari saya? 3.54. Okay, thank you everyone. So this is your final velocity dekat sini. Specifically here. Specifically, I have to say that. Specifically at this point, that is your velocity. If you get this velocity and you say it's here, no, it's wrong. It's wrong, It's not that. Because we know that akan ada something else kacau dia punya velocity ni. Okay, so now we want to know the maximum distance D. The block travels up the frictionless incline if theta is equal to 30. So now we padam balik semua ni. This is now our EI. And this is point C is our EF. So this is our EI. Sorry. Our EI is at the equilibrium point where we have velocity of 3.54. And this is going to be our EF. Point sini and this point. So the way that I can find out D, hopefully, is to find out what is the height over here. Hopefully. So I want to know what is the height. So if this is started with KE and I have an MGH of equals to 0, when I reach this point, I'm supposed to stop, right? So KE over here is 0. And I would have some MGH equals to something. And from MGH equals to something, I would know what is my H. So let's try to have EI and EF over here. Hopefully kita boleh cari D. So EI equals to EF. So this becomes KE plus UG. Now we're not talking about the spring anymore. We're talking about gravitational potential energy. We are going to do work against gravity. So KE final plus UG final. So let me write that initial, final. Okay, so besar ke dapat? KEI is 1 over 2 M 3.54. Okay, and then our UGI, we are at our reference point. Our ground is always our reference point unless we want to make our lives hard, but we don't. So this becomes 0. So this becomes mg times 0. Remember, the reference point kita yang pilih. Kita pilih as ground. Kalau nak tukar boleh, tapi jangan susahkan diri sendiri. So our KE final, we are going to say that it is equal to 0. Sebab when we reach point C, we need to stop. KE equals to 0. So this is 0. Ataupun 1 over 2 mv equals to 0. Plus mg h of something. The h is what we're trying to find. Okay, so now my question is, can I say that I reach the same height from here to here versus if I start from here to here? Will I reach the same height? Will I reach the same height? I'm not asking about D, I'm asking about height. Will I reach the same height if I say my KE is converted into MGH over here? Will it be the same height versus if I have a V of a different V over here to this point? Okay, so ada orang jawab. So let me check. So Haikal said, oh yeah. Kasih said same, yes. Amy said same. Feli said yes. Shaki said yes. Okay, so everyone, quite everyone lah. Most of you guys are saying yes. Kalau kita nak start dari sini, what would be different about our equation? If I'm starting here, my V is 3.54 and this is my KE over here and I am going to convert it into MGH. If I start my EI from here, what would change? Apa yang akan berbeza kat sini? Any guesses? Adakah V kat sini sama dengan V kat sini? Would it be the same? Tak. Okay. So semua orang macam tak pasti So Feli is saying same. Okay. So here our UG does not change. Our US does not change. We don't have friction. We don't have friction? That's your hint. Would my V be the same? Okay, let's just try this question. Okay, let's continue. Kita try dulu. Kita tengok jawapan apa kita dapat. So this would be 0, 0. So my 1/2 mv squared will be converted into MGH. We can cancel this out. So 3.54 squared divided by 2 times 9.81 divided by 9.81 akan dapat H as 0.639. So if I wanted to know what is my D, I can use my sine equation ataupun trigonometry. Sine of 30 degrees is equal to opposite over hypotenuse. Where opposite is our height, 0.639, and hypotenuse will be our D. Specifically from this point to this point, sebab angle kat sini. Kalau saya nak cari D from here to here, what would change? If I wanted to find the D from here to here, apa yang akan berbeza kat sini? Come on guys, this is geometry. Geometry senang. What would change? The hypotenuse would change, betul. But I'm trying to find the hypotenuse. The adjacent would be, the D would be different, betul. But I'm trying to find the D. What will change in my equation to get a different D? The theta, betul Haikal. The theta would be different. So if my D was from here to here, my theta would be different. Tak sama korang. So this would be different. Kat sini ke sini dah lain dah. Ke sini sama. Sini dengan sini lain, angle akan lain. H dengan sini lain. I mean, the angle would be different lah because of trigonometry. So this would not be sine 30, it would be something else for you to find the distance from here to here. Therefore, bila kita dapat sine of 30 ni, walaupun kita ada height sahaja and we have the sine of 30, we can find out what is the D specifically for this part. Sebab apa? Sebab angle ni specifically untuk this part to this part. This angle is specific. If We wanted to know what is the D from here to here. Why am I using the same color? It's so difficult to see. If we wanted to find out what is the distance from here to here, the angle would not be 30. It would give us a different angle. And from that angle, kita akan tahu a different D. So this works because of that. This works because of trigonometry. So back to our question, I asked you, what is the velocity over here? Would it be the same as here or not? So this is a horizontal plane. It is frictionless. Am I doing any work to overcome anything? Okay, semua orang macam confused. Okay, so from here to here, let's say kita cakap V kat sini adalah KE equals to KE sama dengan sini lah, 3.54 squared ni. Let's see what happens. So if I say KE starts from here, this is my EI and this is my EF. KE is the same, then I would get my H. Okay, nanti korang confused. Let's do it. So let's say saya cakap V dekat sini, kat 0 ni sama dengan V kat sini. So the V is equal. Okay, the V is equal. So V at this point is equal to here. So this V is 3.54. I'm assuming the V does not change. Force is 0. So if this is my EI and this is my EF, EI is equal to KEI plus 0 equals to KE final plus UG final. So this would be 1 over 2 MV final, sorry, V initial squared. And this would still be MGH. And I would still get H as 0.639 tadi. Same answer. Why is that? Kenapa jawapan dia akan sama? Pelik tak? Okay, so remember our work energy theorem. Work energy theorem states that if I have work on acting on the block, therefore I would have a change in energy. Now we are not doing any work on the block because there's no friction. We are not trying to overcome anything. So the friction force is equal to 0 here. Therefore, our net work done on the block is also equal to 0. Therefore, the change in KE is also equal to 0. Therefore, U should be equal to V. So U over here is equal to this V. That's how it works. Faham ke? Kenapa W equals to 0 here? This goes back to our W net tadi. Mana equation tadi? Yang kita cerita panjang tadi. This one, was it? No, forgot. We talked about W tadi. Mana dia pergi? Jauh juga kita belajar. Okay. I told you WNC is equal to delta KE on a horizontal surface. This is a horizontal surface from B to C. Lebih kurang je. But here, we have friction. So we had to do work to overcome the friction. So benda ni is not equal to 0. But in our example just now, our friction was 0. So WNC equals to 0. And therefore, change in KE is also equal to 0. When we don't have any change, it means that the value is constant. So back to our soalan tadi, jauhnya kita belajar. Okay, so back to our, is it this one? Yeah. So back to this one, W is equal to 0. Therefore, V is equal to U. Therefore, KE initial minus KE final minus KE initial equals to 0 because tak ada change. Sebab sama Okay, so that is your part A. Part A baru, my god. Okay, part B pula. Last one, sikit lagi. How fast is the block going at half its maximum height? How fast? So let's see jawapan kita betul tak tadi. Ini jawapan kita apa? Height is 0.639. D is, I tak kira. I didn't calculate. Sine 30 is equal to 0.639 over D. So D should be sine 30 times, 0.639 divided by sine 30. Kenapa dengan kalkulator saya? Saya rasa kalkulator saya rosak. So 0.639 divided by sine of 30. Okay, dapat dah. 1.278, 1.28 meter. Okay, so let's see. Jawapan dia sama tak? Yay, sama. Okay. So it works because it is frictionless. That's why we could assume that U that we got over here is equal to here. It's the same. U and V is equal to the same value because it is frictionless. If it has friction, this would not be right. Akan salah. Tak boleh lah pakai cara ni ya. So this only applies if it is frictionless. Okay, next one. Kalau ada yang tertidur, wake up. Last one. So B, how fast is the block going at half its maximum height? So I want to duplicate this. Sebab equation kita dah ada. I just want to plug it in. Half its maximum height. So half its maximum height. Let's use this one. Now it's going to be H equals to how fast is the block going at half its maximum height. So it's asking us for V at H over 2. So it becomes a little bit complicated. Tak complicated mana lah. So this is our equation. So here we know that if we, kenapa saya punya balik kat sini? If we started from here and we ended at C, we would come to a rest. So our KE is 0. But if we arrive at H over 2 at this point, we know that we are not at rest yet because perjalanan masih jauh. So we know that there is some velocity over here and we need to find it. Okay, so using this equation, it's still frictionless. So 1 over 2 mvi squared plus with, we start from the bottom of the incline and that is equal to 0. And at this point, we have KE and we also have UG. So this energy is converted ataupun transformed into two types of energy. So 1 over 2 mvi plus 0 equals to 1 over 2 mv final squared, this is squared, plus with mgh over 2. And we know our h over 2 is equal to 0.639 over 2. This is the height. Macam mana kita boleh pakai value ni balik? Sebab ni part B. So kita dah assume kita dah solve part A. So kita boleh pakai value from part A. So 0.639 divided by 2. Betul ke tadi 0.639 tu? Oh yes, betul. From here. Okay, so 0.639 over 2. And we have our V initial. We need to know what is our V final. So senang je lah. You just plug in. M cancels out. 1 over 2. 3.54 squared equals to 9.81, 6.39. Kenapa saya tertinggal yang tu? 1 over 2 V final squared plus 9.81 times 0.639 over 2. The only unknown here that we have is V final. So I am predicting a V final that is slower than, that is slower than the initial velocity. Sebab apa? Sebab kita start from here and we come to a rest. So naik pada sini, as we go along the incline, we are supposed to decrease in velocity so that we can finally achieve V equals to 0. So kena slowly berkurang lah. So I'm expecting V final to be smaller. Kalau dia lagi besar, maksudnya jalan kira korang salah. So double check on that. 3.54 squared divided by 2 minus with 9.81 times 0.639 divided by 2 times 2 square root that. So I would get my V final as 2.50 meter per second. So it is slower than our initial value of 3.54. Okay, can you close the door, please? Okay, okay, bye. So this is our velocity at this point. From here, this point over here, it is 3.54 kat sini, 2.5 kat sini, kosong. So habis dah kelas hari ni. Next class lah, tomorrow lah kita belajar impulse. Video Ian tu kita sabar-sabar dulu. Okay, any questions so far? Hari ni macam terlajak sikit masa. Everyone's okay? Kenapa Haikal ada 2 orang kat sini? Syakira pun ada 2. No, ada 1 je. Janganlah pergi. Esok saya ada lagi. Esok pukul 8 Esok jom kita tangkap gambar. Semua orang bersiap-siap lah. Semua orang pakai comel-comel, okay? Doctor, why we need to split into 2 parts? Which part Ya Allah, sekarang tak mandi lagi ke? Spring part and incline part. Kenapa kita kena split into 2 parts? Let's see. Kejap, saya check balik. Kalau kita tak split, boleh ke kita solve? Kejap So you want to convert this terus kepada MGH. I guess it would work sebab ni initial. Initial adalah ikut ke sini, frictionless. So dia kan sama dengan sini. Boleh. Boleh. I think it will give you the same answer. So sebenarnya saya ikut jalan kira yang jauh. Saya tak tahu jawapan dia macam mana. Let's see. Dia buat direct ke tak? So kat sini dia buat direct 1/2 KXI equals to MGH. Yes, you could do that as well. Tapi equation ni pening kepala tengok. So you can directly use the potential, the energy over here, terus convert jadi ke sini. Boleh. You would get the same answer because why? Sebab everything is frictionless, so you're not losing energy anywhere. The one that you started with is the one that you will end with. That's a good point, Feli. Boleh. Penat beli perfume. Nanti naik cuti ada quiz ke doktor? Naik cuti bila? Cuti bila korang? Saya tak tahu jawapan. Bila cuti Nanti saya check balik. When is? Ada cuti ke?
Next week.
Oh, next week cuti. Week 9. Oh, week 10 korang cuti. Seminggu Saya tak cuti. Korang je yang cuti, nangis. Sebab tu saya tak tahu cuti bila. OIO. OIO siapa? IOI. Tapi orang lain tak ada. Kita tunggulah semua orang balik duduk kat UPM, nanti kita jumpa ramai-ramai. So naik cuti ada exam ke tak? Week berapa tu? Kita week 9. Sorry, this is week 9 kan? Week 9. Week 12 ke week 13 exam? Bukan week 10. So I know it's for sure it's around 12 or 13. Penilaian, bukan quiz it's ujian 1 and it will be 20%. Final after week 18. Maksudnya habis kuliah semua baru final exam. So tu lambat lagi lah. Yes. So I will double check on that. Saya tak ingat sebenarnya tarikh dia bila. Penilaian 1. I think around 12 to 13. Saya confirm balik. Okay, other questions? So tomorrow everyone pakai comel-comel sikat rambut lelaki, yang perempuan pakai tudung. The girls yang tak pakai tudung, your hair, get ready, kita tangkap gambar, okay? Tomorrow saya pakai makeup elok-elok sikit. Hari ni saya pakai cincai je. Okay, bye korang. So I'll see you tomorrow. Have a great rest of the day. Oh, so ada soalan. So ada soalan. Yes, yang bab 3 tu. Okay, so siapa yang nak stay boleh stay. Siapa yang tak nak stay, you can go. So ada soalan regarding chapter 3. Kejap I'm going to share my screen. I need to turn on. So siapa yang nak pergi boleh Okay, bye. Share, I share Telegram. Kita share. Okay, kita solve tak ada privacy kejap. So solve punya soalan. Mana panjang pula kita punya conversation. Doktor mana so saya tak ingat Sekejap. Doktor remind. Okay, this one. I forgot. Okay, this one. Can you guys see this? Tak nampak. Nampak tak? You are nampak kan? Okay. Let me screenshot this. Kelabunya. Sekejap. Okay, and then kita letak dalam slide kat sini. Here's picture. Okay. So is asking, if I'm not mistaken, kenapa? Okay, let me read back the question. Oh, kat sini ada soalan dia. Okay, morning doctor, may I ask why for M2 net fx equals to MA? Where is M2? M2 adalah the box here. Kenapa MA is equal to mg sin theta minus t? Okay, tengok sini Kita ada mg sin theta to the right and tension over here. So condition kita adalah for mass 2 fx equals to m2a equals to m2g sin theta minus t. Okay, this is my equation over here. But why is mg sin theta minus t instead of t minus mg sin theta? Since m2 we use net fy equals to t minus mg. M2 kita pakai net fy equals to t minus mg. I think so tersilap tulis ni. Dia tulis M2, this should be M1. M1 kat sini kita pakai t minus mg. Tapi untuk mass number 2 kita pakai mg sin theta minus t. Okay. So again, kita baca soalan balik two packing crates of masses M1 10 kg and M2 is over here. M2 is 3.1 kg connected by a light string that passes over a frictionless pulley as in the figure below. The 3.1 kg crate lies on an incline. Find the acceleration of the 3.1 kg crate. Oh, so this is from web assign that I copied. Okay, so punya soalan is, kenapa saya punya fx m2a, okay, this is our free body diagram. My free body diagram is mg sin theta and t is over here. So I write it as mg sin theta minus t, which means that this is my positive sign. But for my M1, I see that T is my positive and my mg is minus. So let's discuss about that. Okay. Stop sharing. Okay, so if we look at this diagram, we know that if we are moving down here, kalau kita punya, kenapa saya tak boleh draw? Sekejap, kenapa saya tak boleh draw? Okay, boleh dah. If I am moving this block, either kita akan pergi ke bawah sini ataupun ke sini, kita kena pilih salah satu lah. Either we are expecting this mass to go down here ataupun we are expecting the mass to go down here. And we chose that our block M2, let me label this as M2, this is M1. We assume that M1 would be moving this way. This is our motion. The motion is going down. And I told you guys, we need to pick one direction as our positive. So if this guy is going down, I want to say this as positive. I would say this is my negative, right? This is my positive and this is my negative. If this block is going down, which way is my block going? For M1, it is going up, right? It is going up. So if this guy, if M2 is going down, my mass number 1 needs to go up because they are connected by a spring. Spring ada string. Saya tarik seorang, saya tarik lagi seorang juga. So they are connected by the same string. Now about the positive sign, if this guy going this way is positive, this guy going this way should also be positive sebab motion dia ke atas, motion ke bawah ke sini positif, motion ke atas pun kena positif lah, so that kita boleh samakan. Faham tak? Kita bergerak macam ni kan, so pergerakan ke sini tu positif, pergerakan ke sini tu positif, therefore ke sini positif, ke atas positif. This is the assumption that we made. So kalau nak tulis free body diagram untuk M1, the T would be positive, the mg would be negative for our mass number 1, and for mass number 2, our mg sine theta would be positive and our T would be negative. Okay, so I hope that helps. Faham ke?
Faham.
Okay, bye-bye.
Thank you, Doktor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome, bye-bye.
Thank you, Doctor.
Bye-bye.